right, so here we go. So we did the exploration. And it says, an inverse relation interchanges the input, that is the x's, and the outputs, the y's. So if we want to find the inverse of an equation, let me give you some steps. Step 1, switch x and y. So that's why in my tool belt today I have this light switch to help us remember. When you're dealing with an inverse, you switch the x and the y. Step 2, solve for this new y. Step 3, new y is the inverse. So if you have f of x, its inverse we write like this, f inverse of x. If it's y, we write it y inverse, but it's like, it looks like an exponent, but it's not an exponent. It's in that location.
That's what we did with the matrices.
Yes. Yeah. Yeah, exactly. All right, so in example 1, it says find an equation for the inverse of the relation y equals 3x minus 5. So step 1, switch the x and the y. Okay, so now it's x equals 3y minus 5. Then step 2, solve for new y. So we would add 5 and divide by 3. Now, it is perfectly fine to have x plus 5 divided by 3, or you could have divided them individually. Now, step 3 says new y is the inverse. So, you're going to want to write it with that, you have to write that it's an inverse. So we're going to then say it's y inverse. I'm going to go ahead and break it apart so that you can see both answers. Writing it as one fraction or as two fractions are equivalent. It does not matter. Okay? All right, example 2. Find an equation for the inverse of the relation y equals negative 2/3 x plus 2. Step 1, switch x and y. So this becomes x equals negative 2/3 y plus 2. So I'm going to subtract 2. And then what do I need to do to get y alone? Multiply by the reciprocal, and I like that mathematical language there. You're going to multiply by the reciprocal, so that's negative 3/2 times the quantity x minus 2. There is nothing wrong with leaving your answer like that product, but you would need to take one extra step and do y inverse. I'm going to go ahead and show distributing the negative 3/2. That would give me negative 3/2 x. Then a negative times a negative would make it positive, and negative 3/2 times negative 2, the 2's cancel. Okay? But make sure when you're writing your final answer, you have either, if the function was f of x, make it f inverse of x. But if it's y, write y inverse. All right, then there's a definition. Functions f and g are inverses of each other provided f of g of x is x and g of f of x is x. So the question that you guys asked a moment ago is not that they're equal to the same thing, it's that they're both equal to x. Okay, that does have to be true. So let me pause here a moment, because really this is as far as I wanted to get today, is that you can either, with a table of values, switch the x and the y values, and that gives you the inverse. You can, in an equation, switch x and y, solve for new y, and then you have an equation of the inverse. You could take the graph of a function and reflect it over the line y equals x, and that gives you the inverse. The last thing is, if you think you know the function and its inverse, you can verify that it is the inverse by doing f of g of x and g of f of x and showing that they're both equal to x.